In this lecture, we are going to send some HTTP requests as we learned before using the socket module, and then search through the response that we receive from the related web server. So the code that we wrote before was in a file named client-server.py. Here was the code. You saw that we created the socket, we connected to a web server like this to the port number 80. The reason for us to connect to a port number 80 was to get the related response in the plain text, and then we send this data which is in the HTTP protocol format. We send it, we wait to receive the data, and then close the socket. In here, what you are going to do is to search through the response. So first of all, what you are going to do is to import the RE module for the regular expression. So in here we say import RE, and then what we are going to do is to first actually let me just define this. I say A3 because of the receive function that is somehow different from other methods in the socket module. It creates a loop. What I'm going to do in here, I want to outside the loop. I don't want my program to hang forever, so I just say A3 is equal to A1.receive 1024. So after we send our data, we want to create a loop to receive some data. Now we say if the data that we are receiving up to 1024 bytes in each step, in each loop. So after we receive some function, we want to check some data. We want to check if the length of the data that we have received is greater than the 0, then we want to just go through the loop. If not, well, the loop won't be repeated, and well, we break out of the loop and the program would be over. Also, at the beginning of my program, I want to create a list called list1, and in here, instead of printing this the data that we are receiving, what we are going to do is to search through the data that we are receiving, saying re dot find all, and now we create the algorithm or the pattern that we want to search through the data, which is A3. So how are we going to search through the data? If we look at in this case, the GigaPan source code. So in my Windows, you open our browser in here, and if we go to the gigapan.com and also go for the view page source, you could see that what we are going to search are all in here. For example, if we want to search for the images, if I press Ctrl F and search for the image, all the images are using the img tag. So we could search for the img to see all the images, or we could search for all the links. In this example, let us just search through the links. As you see, links are a tag and then href, but also we might have other kind of links using another tag like link. We might have other tags so that have the href, but in here what we are going to do, instead of searching for different tags like link and other things, we only want to search for the href to see all the links in the gigapan.com. So in here what we are going to say is to say that I want to search for the href equal, and then after then href equal, what we have in here is that we have a double quotation. So we say a double quotation in here. After that is our link, as you see in here, and so our link might contain anything, for example, forward slash, characters, digits, and so on. So we say everything using a dot and then a star. So everything after that up to the double quotation after everything that we got. Now, if we search through it, we would have all the links in here. So we would have href equal and so on. But what we are going to search through is to only show us the link, and we don't want the href is equal. So we learned in the previous lecture that we would use grouping in this way So we say href equal, and then double quotation would be in the first group, and we don't want to show them, so we say a question mark and then a colon in here, so the first group wouldn't be shown. Then we have the second group, which is everything up to the second double quotation. Now we have searched it through everything. We want to save it into a variable. Let's call it r1, and then after that we would want to say list1 dot append and r1. So after the while, after this step, now we want the while to be repeated for the next section of data. So in this case, we say a3 is equal to a1 dot receive and then 1024. So let's say that in the first section we have received 1024 bytes. We search through them. If we have something, we would add it in the list 1, and then we say we want to receive next 124. Even in this case, I think we would have a problem of hanging our problem because, well, guess for example we have 1023 bytes. First of all, we get the first section, we search through them, or 124. Then for the next part, we would again create a loop. I said that receive method would create a loop, so a loop would be created, and then if it is 0, then it would be hang forever before the while would be repeated. So what we could do in here actually is to just say that after this receive, I would want to say if a3, if length of a3 is equal to 0, we would want to break out of the loop. So you see that we could actually make it in a better way. So anyway, just what I want to show you is to just search for different results in here. I'm sure that by some thinking you could make a better program. So in here we press Ctrl O, we hit enter, and then Ctrl X. Now before we run our program, we would want to press Ctrl Shift and T, and then say Wireshark and then ampersand to open our program, to open our Wireshark, so that we could see that how packets are going on to the server and vice versa. So we start sniffing to the ETH2 network interface card, which is the only active niche in my Kali Linux for now. Now in the first tab we run our program, Python client server.py, and we hit enter. So we didn't print the list that we wanted. The program didn't print anything. So after the loop has been created, you would want to print our list, which is list 1, and you press Ctrl O, hit enter, and Ctrl X. But in the Wireshark you could see that different packets have been going on. DNS packet, three-way handshake, we say send HTTP, and then we receive the related HTTP response. In here we send our packet again, but before that we stop the we restart the capture in the Wireshark, and in here we just run our program again. So we haven't captured anything. Let's see what is the problem. So let me just look at this thing. So we have printed our list, and in here we have appended the R1. Somehow it hasn't found any links so that the list would be empty. So before we go on, I would just want to print our data before the searching our data. So in here we say print a3 and press Ctrl O, we hit enter and Ctrl X. So you see this is the first time I'm running this program. That's why we are having some problems. I want to troubleshoot it together so that you could see if the first time you have also have some problem. So in here we hit enter, and you see that the response that we have got is that 400 bad requests. It says that because we have sent some bad requests, we haven't got any response. That's why in this response we don't have any href or links. So we had an empty response in here. So if we look at our program again, you see that we have said get /HTTP 1.1 rn. So I have one extra space in here. Let's just get rid of that. Control O, enter, and Control X again, and we run our program again. So we restart the capture also, even though we are receiving some packets. Yes. So we have got some links in here. You see we have a couple of links, and the response that we have got in here, somehow I think the server gave me a wrong answer, because I think there is a problem with the gigapan.com web server. You see, these are not the source code of the gigapan.com. These are all the Ruby files. So let's just send some data to other web servers. For example, let's say in the washington.edu, which was an example in the previous lecture too. So let's say if you are sending some data to the for example, other websites that are working with the HTTPS, you pay attention that every time you should send the data to port number 80. So in here we say www.washington.edu. Now we press Ctrl O, we hit enter and Ctrl X, and we run our program again. Let me just restart the capture in the Wireshark, and we execute our program. So you see we are receiving some data in here. These are all the data, and yes, we have received everything, all the links in a list format. So we are receiving the data, but the links, I think we haven't got. Actually, let me just look at the program again. So now that we know that we are receiving the data, let me just comment this line. We don't want to print the data, but only the links. So we press Ctrl O, enter, and Ctrl X. We execute our program again. So this is our program again. So somehow even though we are getting all the links in here, but it is in a wrong format, or everything is being printed. I think the reason is that we have said that I want all the links to be printed up to everything to the next question mark. So if we look at the source codes, for example, so if we just look at our data in here again, the last question double quotation that you see, for example, are in here at the end of the source code. So what we could say is to put a question mark in here to say that I want everything to be printed on up to the next question mark. For example, if you open the source code in here, I said href equal first double quotation, then all the links, but we should say up to the next double quotation, not up to the last, which would be printing everything else. So in here we just put a question mark, we press Ctrl O, we hit enter and Ctrl X, and we just run our program again. So you see we have 2 packets, 10 packets now. It was 69, now it is 85, which means that this program is sending and receiving some data. Now the program has been executed, and we have all the links in here. So you see washington.edu, online privacy, and all the other links that we have them in here. You see these are all the different links in this website. So we were able to just use the socket module, which is the fastest module in Python, to print all the different links in a website, but in one web page. Now you could guess that, for example, if we want to just print more links, we could just send some data to other pages to this web server, or we could just search for other things like emails, like links or other things. Actually, let me just check it. So we comment this line and we say, so r1 is equal to re dot find all. So we want to create this pattern to search through the A3, which are the data. And in here, what we are going to say is to say for everything which finishes with @gmail.com in here. So we could say, for example, everything, or we could say just we learned that we could say, for example, D for some digits, W for other things. But what we are going to do is to just search for the email, if there is any email, so it would show us the @gmail.com, and then we could just improve our program to see the username of this email. So we press Ctrl O, we hit enter, and Ctrl X, we run our program. If there is any email, it will show it to us. So this is a typo, find all should be, not find LL. Ctrl O, enter, Ctrl X again. You see in here that we are sending a lot of different packets, 119 to 135. It was 16 packets. So we don't have any data in here because there is not any address that is ending with @gmail.com. Now we may have @yahoo.com, hotmail.com, or other things. What I was going to show you is that you could search through different addresses by the pattern that you could learn in the RE. You could just look at the regular expression online to see all the different patterns that you could find to search for anything that you want.